So we will see bitwise OR and JOR and complements, right? We'll see all these operators in this lecture. So if we'll talk about the bitwise operators, right? So we have bitwise operator, as you can see here. So I have summarized this for easy implementation and understanding. So you can make a notes of this, because lot of time you will struggle sometime, right? So what is bitwise OR, right? So bitwise OR, we are getting the symbol like this, and for that let's understand, if A we have in decimal 5 and B have 7 in the decimal, so in the binary representation we'll have 0 1 0 1 for the 5, and for 7 we have 0 1 1 1, right? So if we'll do A or B, A bitwise or B, then what will happen? 1 1 it will become 1, 0 1 will become 1, and 1 1 is 1, 0 0 0 means in the decimal it will become 7, right? So this is called bitwise OR operator, right? If we'll talk about the AND operator, bitwise AND operator, so we have A and B similarly, and we'll do A bitwise OR operator will use here, right? And so it will become what? 1 1 0 1 1 1 0 1 0 1 1 1. When it is 1 1 1, then it will become 1, right? That we know. So if we'll see A and B, we have seen what? 5, right? So this is called bitwise AND operator, right? Next we have bitwise JOR operator, right? And here we'll use like this, right? This operator. So if we will use the same A and B for the decimals, the binary representation will look like this. So when there is a 0 and 1, right? If any 0 is coming or 1 is coming, right? So in that case it will become 1, right? When 0 is there and it moving to 1, then it will become a like a switch case, right? It will become JOR, right? If we have 1 1, then it will become 0, or it is 0 0, it will give 0 0, but it should be 0 or 1 like a switch, then it will become the alternative value. There is a 0 and 1, so it become 1, so we will get 2. So if we will have A XOR B, then we'll get 2 value in decimal. Coming back to the other operators, so in this case we have bitwise complement operator, and we use the symbol like this, and we have A 0 1 0 1, and we will make the complement, it is become alternate 1 0 0 1 1 0 0 1, and we will get what? 10 in decimal number. Okay, so this is called bitwise operator. Let's understand bit shift operator. So it is very important to understand bit shift operator, because almost all the questions you will see on the bit shift operator. Okay, so how many types of bit shift operator? We have first sign left shift operator, where you will see 2 double less than operator, right? So let's suppose we have in integer, we have n equal to 2 we have, and if we want to make n we want to make a left shift operator, and left shift, we are using left shift operator with a 2, then in that case what we want to do, we want to make 2 bit shift light in the left side, right? So means 2 bit left shift we want, and for that we are using n left shift of 2, means 2 bit we want in the left side. And for that, so for the binary representation of n, we have what? N equal to 2 is 0 0 1 0, right, in decimal. If we'll shift this 2 places, right, in the left side, so it will become what? From this one it will go to the 2 left here, right? And so that we will get what? 1 0 0 0 0, right? So in the decimal number it will become 8, right? So if we have 2, right, and we want to make you can say shift of 2, left shift of 2, right? So it will become what? It will become 8. Okay, another we have sign right shift operator, right? And in this case we have here sign right shift operator, where we'll have 2 greater than symbol, right? And if we have n equal to 8, we'll get 2 back, right? So if we will make 2 shift operator here in the right shift, then we'll get what? Back to 2 we will get here, right here, because the rightmost 2 bits are lost, and since it is shifted to the right of the two places, right? So if we have here, let's suppose n equal to 8 we have, and we want to make shift of 2, means we want to lose actually 2 shift, right? Means from here we want to make here, right? So in this case what will happen, these two will 0, this will become 1, and this will become 0, right? So we'll get 2 here. This is in the decimal, it is 2, right? In unsigned, what is happening, like if we have n 8 and -8, so in the case of negative bits, the sign, or you can say unsigned, right shift are provide different result. You cannot expect that this value will become exact any value, right? But if you have positive numbers like this, right, then you will get shift of that we have already seen that here, right? Otherwise, if it is negative number, it will give unwanted result that you don't expect. Okay, so if we have positive number, so it moves the bits of integer in a given number of places to the right number. Like we have given 2 shifts, so we are going to make a 2 shift of the operator. Okay, if it is 3, then we will come toward 0 0 0 or 1, right? So this will become 1. If it is like what, n shift of 2 or double shift, you will 3, right? Then you will get what, this one value. Okay, so I guess you understood these shift operators, and if you have any doubt in this video, please comment and give suggestion in the comment box. And in the next video we are going to see a question that we have seen in this context. And thank you for watching this video. If you really like this video, please like, share and subscribe this channel. Thank you for watching this video.